Welcome to Electrical Machine Lab. Today we are going to perform a practical on synchronization of alternator with infinite bus or parallel operation of alternator, procedure of parallel operation of alternator and synchronous motor on infinite bus. So in the first part of this practical, we will discuss the different parameters or different components connected in the practical and necessary components and what are the different procedure. And in the second part, we will conduct the practical. Means first practical is the synchronization of alternator or parallel operation of the alternator, and in the second practical, synchronous machine on infinite bus, effect of change in excitation and effect of change in mechanical input to the synchronous machine or synchronous alternator. So this is the machine DC motor coupled with alternator. This is DC motor coupled with three-phase alternator. So this is the DC motor, and this is a three-phase alternator. This is three-phase alternator. The nameplate rating of the DC motor is 3 HP motor, 220 volt, 12 ampere is the full load current, 1500 RPM is the rated speed of the DC motor. Whereas for the three-phase alternator, it is a 2 kV alternator, 415 volt, 2.8 ampere, and rated speed of the synchronous speed of the alternator is 1500 RPM. This is the set. It is purchased under MODROP. I received grant from AICT on the modernization and removal of obsolescence scheme, that is a MODROP scheme. The name of scheme is, the name of project is synchronous machine on infinite bus, where I receive fund 5,35,000 for this practical setup. In this practical setup, and addition to this one, the college has purchased around 6 motor under such scheme also. Now see, this is the All India Council for Technical Education. This is a funding agency, and name of faculty member is myself, Ansari, assistant professor. Now this is the practical setup. It is comprises of 2 panel. One panel number 1, it is the DC shunt motor and three-phase alternator. DC shunt motor coupled with the alternator. So see here, this is the three-phase DC starter, DC 3-point starter. This is DC main supply is there, DC supply. It is connected to the LFA, and this is the field winding. This is the armature winding of the motor and DC field winding of the motor. So here the connection F is connected to the field winding Z, and A is connected through the ammeter, which measure the current of the for this purpose, for the measurement of the DC motor current is there. And next is the field winding. Now second is the three-phase alternator. Is a star connected three-phase alternator whose X and XSS is the field winding. It is excited from the DC source. So inbuilt there is a DC source, variable DC source. This is the DC source, and from the DC source, this is positive terminal and negative terminal. It is connected with the excitation system and to the field winding of three-phase alternator. Now the panel is equipped with a different indicating type of instrument. One is the DC voltage, which is from the source. Second is the DC motor field current. What is the DC motor field current is there. Next is the DC motor current. What is the, if indicate that if something wrong, or what would be the load current of the DC motor. Whereas alternator voltage, excitation voltage of the alternator or the terminal voltage of alternator under loaded condition. Next is the alternator armature current. It is a one phase is connected to the ammeter to measure the load current of the alternator, or simply alternator armature current. Alternator DC field excitation. So when we perform the second practical, that is the effect of excitation over the alternator over the synchronous machine. So this alternator excitation is very much important. What is the DC excitation? Either is a over excitation or under excitation is there. Now it is also coupled with, it is also equipped with 2 more meters, additional meter. It is the power factor meter. So power factor of the alternator. So here the it is the inductive load. So if the indicator goes to this side, so it is a power factor is lagging, and whereas the capacitor, so the power factor is leading one. So this is the unity power factor, and here say it is a 0.99 power factor. This is 0.8, so it is a 0.9, and here this one it is a 0.99 power factor. So here the power factor range is expanded for measurement purposes, whereas it is the alternator power output. This power output is connected from this terminal. One is for the power factor meter connections brought out for the external connection, and this is the watt meter connections are carried out, and from this watt meter a load is connected, a resistive load, 3-phase resistive load. It is connected for the loading of 3-phase alternator. So this is the first part of the practical setup. This is the 3-phase alternator, means DC shunt motor coupled with the 3-phase alternator. Second part of this practical setup is the synchronization panel. This synchronization panel is consist of frequency meter. It measures the frequency of incoming generator as well as the grid one. Second is the phase sequence, which indicate the phase sequence of infinite bus and phase sequence of incoming generator. Voltage, measurement of voltage of the infinite bus as well as the voltage of DC voltage of 3-phase alternator once for the parallel operation. Next is the synchronous scope. So synchronous scope is help to synchronize the incoming alternator with the existing alternator or infinite to the infinite bus. So it shows slow and fast. If your incoming generator is fast, the pointer moves toward the fast direction, that is a clockwise. Otherwise, if the incoming generator speed is slow, so it will indicate the slow direction by anti-clockwise direction. So this is the meter which is connected. Now there are 6 lamps are there. It is a lamp method. Either it may be a dark lamp method or bright lamp methods are there. And this is the synchronizing switch. Initially the synchronizing should be off position, or you ensure that the synchronizing switch should be off position at any cost before this one. So source 1 is the input from alternator, incoming alternator. See here, this is the wire, it is connected with the panel. So it is the source, it is connected from the alternator, whereas the second source is the source which is connected to the grid. So now this is the grid switch is there. After switch on the supply, we can compare the voltage and frequency. Once the voltage and frequency of incoming machine is equal to the grid voltage, then it is ready to synchronize this one. So this is the description of a practical setup for synchronization of alternator, or it may be the procedure to do the parallel operation of 3-phase alternator, as well as to connect the synchronous machine on infinite bus. So this is the some simple description of practical setup. Now in addition to this one rheostat is also connected to adjust the speed of DC motor to produce the required or equal amount of frequency equal to the supply frequency. Now we will move toward the practical conduct of first practical, that is procedure to synchronize the alternator.